Hello, welcome to my data structure finals. This is Anthony Liu. My project is based on I like to collect things, and it's hard to keep track of what's in my collection. I like to collect cards particularly, so I built a project so I can put things into a database sorted by the rarity, name, valued, and to keep track of it. Um, in our Let's clear this out. We made a card class which has our variables for name, rarity, and value, and then we made comparators in a switch case so we can implement it with an insertion sort. So in our insertion sort, whatever we pass in, it'll take it, and then depending on what we are sorting it by, it'll sort it by the higher value, the name alphabetically, or the value. And to do that, we also made it so we would compare two rarities, and then we in our switch case it would whatever it returned a higher in the switch case it was sorted by that method. And also if they have the same value, it would go to the next part and then sort it by the next key value. So if it's sorted by rarity and then they have the same rarity, whatever has the higher value will go over the one of the lesser value. And then we have comparators for name and then prices. And then for our database class, we are using a priority queue and a hash map. The priority queue is our main data structure, so that will keep everything. That's the thing that's going to be pretty much sorted. The hash map is just we use it as an easy lookup. Since hash map keeps everything in a key and a value, it's easy to, when you want to get something from the map, it's just easy to look up. And so we add methods of we have a method to add, remove, and look, and then pull cards, and then print as well. So when we add cards, we'll put it into the map and the priority queue, and then the same thing with the remove. We're moving from both databases, and then here we have the lookup. So we use the map to look up the name of the card, and since the priority queue keeps things in the front of the queue, the highest value, we just have to pull it to pull the highest value card or rarity in front. And our print statement will take cards from the hash map and then print it out into a two-string. And then for our sorting methods, we pull things from the hash map and then we put it into an array, and then we will sort it. And then we also made it so whatever key value that we are pulling, we're gonna sort it and then print it out. And then for our driver, this is where I implemented my GUI. In my GUI, I made a Pokédex. And then in the Pokédex, I have two panels. I have the first panel here, which is our text field. And this second field was going to be the GUI for the output. This is my first time with Java, first semester with Java and GUIs. So I wasn't sure how to tackle this and ran out of time. But here we'll be using the console for everything. So in here we have our text field for name, value, and then here's our rarity. And since there can only be 4 different rarities for a switch case, this makes it so the user can only put in one input of the rarity, considering there's only 4 different ones. And if you don't have one chosen, then they'll just default to whatever's there. And then we added buttons to add, remove, and then print out or view the current cards in the binder. And then we can sort. And then over here was going to be all the sorting methods over here. So right now we have 0 cards in the binder. So let's add some cards. We'll add Charmander. We'll give it a value of 10. And then we may get a common. We'll add it. And then we'll add Charmeleon. we'll go a value of 20, and give it an uncommon. We'll add Charizard. We'll give him a value of 50. We'll make him a rare. Then let's add a Dragonite, and we'll give it a lesser value but a higher rarity. And then we will print and see what's in here now. So again, now we have our Charmander, Dragonite, Charmeleon, and Charizard currently. And we can now sort it. So we sort by rarest. It should put the dragon. I'll put the Dragonite in front, and then followed by the Charizard, the uncommon and common. And then if we do it by alphabetical, it will be Charmander, Charizard, Charmeleon, and Dragonite last. And then for value, it should put Charizard on top, even though it has a lesser rarity. It has a higher value than Dragonite. And then we can test our remove function. We can remove the removal only remove cards from the name field. So we can just remove Charmander, and no matter what's in the value or any checks, the checkboxes, it shouldn't matter. It's just remove whatever's in the name field. So if we remove, we view it. Remove view. It's because the Charmander is capitalized. That's why. Okay, yep. Now Charmander is removed from the binder. So yeah, that's my program. It'll help me sort everything out. The only problem with the priority queue with the hash map implementation is, so you can't add multiple cards of the same name. If you have the exact same fields, all three same fields, and you add it into the hash map, it won't make a separate node unless I'll probably have to implement another ID or something like that. But yeah, that's my program. Thanks for watching.